Hello everyone, welcome back to my general chemistry mini lecture. Today our topic will be the mole calculation. Okay, this I give you a mole calculation flowchart. So you can see the center is mole, and that's the counting term for chemistry. And 1 mole of anything equals Avogadro's number. That is 6.022 times 10 to the power of 23rd. And so I give you the relationship of the mole with all other unit, like the number of particles of small particle like atoms, molecules, ions, or other small particles, even electrons. And so, and to calculate the particles number, if you know the moles, you just multiply with the Avogadro's number. If you know the particles number, divided by the Avogadro's number, you can calculate the moles. So that's the relationship. Now, mass. Mass can be calculated by the mole times the molar mass, if you know the moles. So molar mass is calculated based on the formula. Okay. If you know the mass, you want to calculate moles. That's mass over molar mass. Mass divided by molar mass. Now, volume of gas at SDP divided by 22.4 can give you mole. And if you know the moles, multiply with 22.4, that's called a molar volume. You can calculate the volume in liter of gas at STP. So this must be at STP, standard temperature and pressure for gas. That's 0 degrees Celsius and 1 atm. If it's not STP, then you need to use the ideal gas law to do the calculation. Moles divided by liter of solution can calculate the molarity. That's a concentration. That's the most common concentration for the solution in chemistry. And if you know the molarity and if you know the liter of the solution, the volume, then molarity times liter, it can give you moles of the solute. Molality is another concentration of solution. So moles divided by the kilogram of solvent calculate molality. If you know the molality and multiply with the kilogram of the solvent, you can calculate the number of moles. Okay, that's the flow chart. It's not include all the mole calculation, but that's the most common calculation using moles. Okay, I'll give you some examples to utilize those. Remember, so most common calculation actually is the mass between mass and the mole. Okay. Now this is one question: how many ions in one drop of blood? We know the ions actually is the iron 2. There's a ferrous ions as a cation, as in a hemoglobin in a heme group. And that's the center of the red blood cell to carry oxygen for us. In one drop of blood, how many ions in there? So how to calculate this number? So we need some more information so we can search and we can find in general the normal range for iron levels in blood for adult. Okay, for grown up, it's about 30 to 400 nanograms per milliliter. This is one information we want. We also need to know a rough estimate, one drop of blood, the volume, it's about 50 microliter or 0.05 milliliter. So that's another information we need for this calculation. Now we are ready. So that's enough information. So let's do the calculation. First, we can calculate, since it's a big range, it's a broad range, we can just average it, 30 and 400, 30 plus 400 and divide by 2 is 215 nanogram per milliliter. So we can use this number to calculate the average level of iron. And then we can convert this nanogram per 1 milliliter to the nanograms in one drop of the blood. So this is a proportion. In 1 milliliter, you have 250 nanogram ions, and then in 1 drop of blood, the volume is 0.05 milliliter. How many nanograms? So it's a proportion. Solve the x. 10.8 nanograms. Cross multiplication divided by 1. Okay, so we have this nanogram. We do need to convert this to gram because when you calculate the moles from mass, it's the mass in grams divided by molar mass. So we can convert it to grams. We know 1 nanogram equals 10 to the negative 9 grams. So then we can convert this to grams. 1.08 times 10 to the negative 8. Now we are ready to calculate the moles because now we have mass of the iron in 1 drop blood. And then we need a molar mass of the iron. So we have mass, we need divide by molar mass. So what's molar mass of iron? 55.85. So 55.85 grams per mole. From your periodic table, you can find a molar mass of any element. So now the mass divided by molar mass give you moles. So we got 1.93 times 10 to the negative 10 moles of iron. Okay, so this can be converted to number of the particle, the ions. Actually, it's iron 2 cations. It's also called the ferrous ions. Okay, so now we can use the mole times Avogadro's number. So when you know the mole, multiply with Avogadro's number, you can get the particles number. So the multiplication give you 1.16 times 10 to 14 iron. Okay, this is a big number. So you can see even in 1 drop blood, you have about 100,000 billion ion in that 1 drop blood. Okay, this is the first example we use the mole calculation. You can see you have to go through the moles. Another example I'll give you is to calculate the carbon atoms number in a 2.5 carat diamond. So 1 carat equals 200 milligram or 0.2 grams. Okay, that's the relationship between a carat and grams. And that you can calculate, based on this, you can calculate 2.5 carat equals how many grams? 2.5 times 0.2 grams per carat, you get 0.5, so half grams of diamond. It's a big diamond. Okay. And then when you have the mass and you want to calculate the atoms number, you need first to calculate the number of moles. And we know the diamond is actually the pure carbon. It's a type of form of its carbon. Of carbon can form other type of material like graphite or graphene. But diamond is the one type of that's called allotrope of carbon. Okay, so carbon's molar mass is 12.01. So when you have mass divided by molar mass, we can calculate the number of moles of this carbon in this big diamond. That's 0.5 divided by 12.01. It's 0.042 mole. Now, when we have this number of moles, we can use this multiply with the Avogadro's number. Then you can calculate the number of carbon atoms. That's 2.5 times 10 to the 22. That's a huge number. Okay. Let's look at another example. This time, we need to convert the volume of gas at STP to mole, and then convert to mass. Question, how many grams of helium in a helium balloon at STP? So now you also need some more information. So how big is the balloon, right? So you can search out, and a typical helium balloon used for parties or event is usually around 3 to 15 liters. So then that's enough information. So based on this information, we can first, the average volume of the typical helium balloon will be the average 3 plus 15, 18 equals 18, divided by 2 is 9 liter. So now, at STP, 9 liter can be converted to mole, just divided by 22.4. That's called a molar volume. So you can get 0.4 mole helium. This is at STP. Okay. And then when you have moles, you want to calculate the mass, then you need to use the moles times molar mass of helium. So helium's molar mass is 4. So 0.4 times 4 is 1.6 grams helium. So in an average size of balloon of helium, so the mass of the helium inside is about 1.6 grams. Okay. One more example here is how many molecules in a small crystal of table sugar. Okay, so we need some more information. Let's find out. Okay, this is the information we need. What's the mass of a small crystal, right, of table sugar? So table sugar is called sucrose, and the formula is here: 12 carbon, 22 hydrogen, and 11 oxygen. And a small crystal of table sugar has a mass around 6 milligram, about 6 milligram. Okay, so that's enough information. Now, so we need to convert the mass to grams. This is milligram, right? And then we know 1 milligram equals 10 to the negative 3 grams. So this conversion gives the mass in grams of the one small piece of table sugar. 6 times 10 to the negative 3 grams of this formula. That's table sugar. Now, when we have mass, if we need to calculate the number of molecules, you need to calculate the moles first. How to calculate moles from mass? That's mass divided by molar mass. The molar mass of a table sugar, you need to calculate based on the formula. So we have carbon, hydrogen, and oxygen. So there are 12 carbon, 22 hydrogen, 11 oxygen. Add them together. So the molar mass of this table sugar was 342.3 grams per mole. Okay. Then we can use the mass divided by this molar mass, 342.3. We can calculate the number of moles of this table sugar. That's 1.75 times 10 to the negative 5 mole. And then when we have this number of moles, then one more step, we can calculate the number of molecules. Just use the mole times Avogadro's number. And then we have 1.06 times 10 to the 19 molecules. That's also a huge number. Just one small crystal of table sugar, we have this more than billions of molecules. Okay. One last example, it's a different question. How small is a water molecule? Another way to say what's the size of the water molecule, one water molecule. Okay. We know the density of water is 1, but actually the most precise number at 4 degrees is 0.9998. So usually we just use 1, just for convenience. Okay. So that's the information we can use. Now, we can calculate the volume of 1 mole water. Okay, so then we need to know the molar mass. Okay, so why we need the volume of 1 mole? Because then when we know the volume of the 1 mole water, we can use that volume divided by Avogadro's number. We can calculate the volume of each single water molecule. So we need water molar mass. So water is H2O. We need hydrogen. Oxygen is the molar mass. So molar mass of water is 2 hydrogen plus 2 oxygen. So 18.02 grams per mole. That means 1 mole water is 18.02 grams. And then we know the density is 0.998. So the volume will be mass divided by density. So 18.02 divided by 0.9998, it's again 18.02 milliliter, because the unit is grams per milliliter. So that is the milliliter, is not an international unit. So we can convert that to cubic meter. That is the international unit. So 18.02 milliliter times the conversion factor, we know 1 cubic meter equals 1,000,000 milliliter. And then we can find the volume in cubic meter, 1.802 times 10 to the negative 5. This is volume of 1 mole water. So then what's the volume of single water molecule. Actually, there's an assumption here. We assume that the water molecule is next to each other and there's no space among them. So that's just an assumption. Okay, so roughly we can calculate the one molecule of water, the volume will be the total volume of 1 mole divided by Avogadro's number. So then we can calculate 2.992 times 10 to the negative 29 cubic meter. That is roughly the volume of one water molecule. Now another assumption is assume the water is a cube, it's cubic. Although we know it's not. If you know a little bit more chemistry, you know the shape of the water is bent. But now, just for the convenience of calculation, we can just assume the water is like a cube. Then, when you know the volume of the cube, you can calculate the edge length. So that will be just the cubic root of this volume. So we can calculate that. That equals 3.104 times 10 to the negative 10 meter. So that is the size, the edge length of the cube. If the water molecule is this big, that is the volume of this cube. So this is about 0.3 nanometer. So now you have a roughly idea how small is the one water molecule. Okay, that's all the information, all the examples I want to give you. If you have any questions about the mole calculation, please let me know. Okay, good luck.